This video is about population size and how it's influenced by birth rate, death rate, immigration, and emigration. What you'll learn this year in biology is that the smallest part of anything is called an element. Elements come together to form organic molecules. Molecules come together to form cells. Cells come together to form tissues. Tissues come together to form organs. And organs come together to form organisms. Well, what happens after organisms? Organisms live in an environment. Many organisms together are called a population. Many populations together are called communities. And if you take a community and add all the non-living things like soil and air and rocks, it's called an ecosystem. We will be studying populations in this chapter. A population is a group of animals of the same type that live in an area. Populations can change in size, and sometimes organisms are born into a population, and that is called the birth rate, the number of organisms born in a particular time. For instance, look at 1980 on this graph. In 1980, the population of birds in this case was pretty low, like maybe 10 birds in this population. And then look at 1985, it's about maybe 75 birds. The birth rate must have increased a lot because the population increased. There are more organisms in the population in 1985 in relation to 1980. There must have been a high birth rate. Sometimes organisms in a population die, and this is called the death rate, the number of organisms that died in a particular time. Notice between 1985 and maybe 1987, do you see how the population of birds has drastically decreased? That must mean that the death rate increased. There was a lot of birds dying, therefore there was a high death rate. What could have increased this death rate? Well, maybe the number of predators. If the number of predators increased, then more birds would die, therefore a higher death rate. What if a different population of birds entered the environment and were competing with the original population of birds for food? What if they both ate worms? What would happen to the bird population? Well, the death rate would increase, and therefore more birds will die and the population will decrease. Same idea about food. If there's less food, more organisms will die, and therefore the death rate increases. What about space? If a part of a forest gets cut down, there's less space for the birds to live, and therefore that space has decreased, and there isn't room for all the birds to live, so some die, therefore the death rate increases. So a variety of things could possibly increase the death rate. When a population drops, it's because the death rate usually has increased. In populations, you have both births and deaths. So how do you figure out how the population size will change? Well, growth rate is birth rate minus death rate. So for example, if there are 200 birds that are born, that's the birth rate, and there are 150 birds that die, that's the death rate, what is the growth rate? 200 minus 150 is 50. The growth rate in this particular example is 50. Finally, population sizes also change if organisms move into or out of a population. When organisms move into a population, it's called immigration. This increases the population size because obviously organisms are moving into the population, therefore more organisms. Organisms can also move out of a population. This is called emigration. This would decrease the population size. If organisms leave a population, therefore the size of the population would decrease. Let's look at this graph. This graph is pretty much showing you an increase in the number of organisms in a population. So notice the y-axis says number of individuals, the x is time. Therefore, looking at the graph, it looks like the number of individuals increase over time. The population is increasing. So according to the graph, is the death rate greater than the immigration rate? Meaning, are more organisms dying than are coming into the population? Well, if more organisms were dying than coming into the population, you would see a decrease in the population size. So the answer is no. Because the population is increasing, number one is not true. Is the emigration rate greater than the birth rate? So we're saying, are more organisms leaving than are being born? If more are leaving the population than are being born, the population size should decrease. That's not what the graph shows, therefore number 2 is wrong. 3. Is the immigration rate equal to the emigration rate? Meaning, those that are coming into a population equals those that are leaving a population. Well, if that's the only two variables we have, it would mean that the population stayed the same if those that came in equaled those that left. The population here is not staying the same, it's increasing. So number 3 is wrong. What about number 4? Is the birth rate greater than the death rate? Meaning more are born than are dying. Well, if more are born than are dying, the population would increase. And that is exactly what the graph is showing you. Therefore, number 4 is correct. So when scientists try to determine population sizes, they have to look at everything together. The birth rate, the death rate, immigration and emigration. So let's try a practice problem with all of those variables. Let's pretend that there are 100 ducks in a population. In 1 year, 50 ducks are born. That's the birth rate. In 1 year, 20 ducks die. That's the death rate. Also, 10 ducks immigrated into the population and 5 ducks emigrated out of the population. After 1 year, what is the new population size? Well, we start with 100 ducks. 50 were born, 20 die. 10 came into the population, 5 left the population. Therefore, the new population after 1 year is 135 ducks. This is all I have for the video. Write down your questions and ask me in class.